Dear students, welcome to EPG Pathshala. Today in this module, we will be discussing about size reduction, which is one of the waste processing techniques. To begin with, the learning objectives of this module would be: what is size reduction? What are the ways by which size reduction can be done? What are its objectives or its needs? And we will look into the different classification. Then we will look into the different types of equipments which are used for size reduction. We will also be studying about the various mechanisms which is involved in size reduction. Finally, we will also look into the various laws governing size reduction, and we will end this module by discussing about the various criteria which is needed for selecting a size reduction equipment. Now let's see what is size reduction. Why size reduction is important? As I told you, size reduction is one of the important waste processing technique. Now why do we need to do size reduction? Before that, what is actually size reduction? Size reduction is a process by which the waste materials are cut down or shredded into small pieces. Size reduction will help in treatment and recovery of materials from waste. When you shred a waste, it will reduce the size. When the size reduces, it increases surface area. When the surface area is increased, it will help in proper treatment. Secondly, when a size is reduced, the resource recovery is also better. So, it is always essential to go for size reduction. And additionally, the size reduction will also decrease the requirement of landfill or the space we are going to dump the waste. So, with this brief introduction, let us look into the size reduction in detail. As I told you, size reduction is a process of reducing the particle size of a substance to a finer state. That is, the smaller pieces are reduced to coarser particles and then to powder form. Size reduction process is also referred to as comminution and grinding. It reduces the bulky items to particles so that the size becomes compatible with the processing equipment. Towards your right, you can see two images which is an example of a size reduction unit. This is a shredder, and you can see how particles are being reduced into smaller particles. Now, what are the objectives of size reduction? The major objective or need for size reduction is it will increase the surface area of the reacting species so that the chemical reaction can be fastened up. It is also possible that it will enhance the biological activity if any biological organisms are inoculated with this material. It will also increase the mixing. That means you can achieve better mixing. Next, to dispose of the solid waste easily. The size reduction also helps material handling better. It will also help to reduce the size of fibrous materials so that it will enhance the process of treatment so that a better efficiency can be achieved. It will also help in the separation of desirable components in a better way. Now, let's look into the classification of size reduction. The size reduction is classified into three types. One, coarser size reduction. Second, intermediate size reduction. And the third one, fine size reduction. Coarse size reduction is designated for hard, irregular, solid particles having a size in the range of 2 to 96 inches or larger than that. The major equipments used for coarse size reduction includes jaw crusher, gyratory crusher, toothed roll crusher, and hammer mills. When you talk about intermediate size reduction, it is designated again for hard, irregular solid particles having a size range of 1 to 3 inches. And the various equipments used for intermediate size reduction includes cone crusher, crushing rolls, stamp hills, and disintegrators. The size of particles where fine reduction is done includes 0.25 to 0.5 inches. Again, these particles can be hard and irregular. The equipments used include ball mills, tube mills, and roller mills. The types of mills are for high energy milling. Towards your right, you can see images which are designated as A, B, C, D, E, and F. A is a ball mill, B is a planetary mill, C is a vibration mill, D is a stirring ball mill, E is a pin mill, and F is a rolling mill. Now, this is an animated picture which shows how the particles are shredded in a ball mill. Now, basically, ball mill consists of a hollow cylindrical shell which rotates about its axis. The rotation can be horizontal or it can be tilted towards an angle. The cylinder is partially filled with balls which are made up of steel or stainless steel or ceramic or rubber. The inner wall of the shell is made up of abrasion resistant material which can be either manganese steel or rubber. The second type of ball mill is planetary ball mills. In this, it is a laboratory scale ball mill and it is smaller in size when compared to other ball mills. It consists of one or more grinding jar fitted eccentrically on a wheel which is so called a sun wheel. The direction of movement of the sun wheel is opposite to that of the grinding jars. The grinding balls in the jar are subjected to superimposed rotational movements. The difference in speeds between the balls and the grinding jars produces an interaction between frictional and impact forces which results in the release of huge amount of high energy. Similarly, the same principle is applied for vibrational mill. In a stirring ball mill, a stirrer is provided where the stirrer acts like a shredder and it shreds the particles into smaller size. Now, coming to the advantages of size reduction gives uniformity for particles. It also helps effective drying, it improves the dissolution rate, it provides uniform mixing and drying, it increases surface area, and finally it also increases the rate of absorption because smaller the particle size, greater would be the absorption. Now, let us look into the mechanism which is involved in size reduction. The basic mechanism which is involved in size reduction is 1. Cracking, crushing, grinding. These are the three different ways by which the bigger solid materials are broken down into smaller particles. Cracking, as you all know, it gives a coarse particle. In crushing, you get a little finer particles, whereas in grinding, the particle size can be reduced up to a powder. The mechanism, if you can see in more detail, it involves 4 different types of mechanism. First one is impact, second compression, third shear force, and fourth is attrition. Under impact, particle concussion occurs by a single rigid force. For example, you use a hammer to break the particle so that it gets broken down into smaller pieces. Second type of mechanism is compression. Under compression, particle disintegration is done by 2 rigid forces. It is also called as a nutcracker. You can see the image towards your right, which will clearly explain what is compression. The third type of mechanism is a shear. Shear is nothing but the particle is compressed between the edges of 2 hard surfaces. The last one is attrition. Attrition is a process where particles are produced from scrapping or collision against each other. Now, let us look into the various laws which govern the size reduction process. During the size reduction process, the particles experience a mechanical energy, due to which they get distorted and they become tensile or loose, and further they crack. After that, it is broken down into smaller pieces or finer particles. The energy required for particle size reduction is a function of input and output of particle size, hardness, strength, and other properties of solids. Basically, 3 laws governs the size reduction process. One is Kick's law, second Rittinger law, and third one is Bond's law. According to Kick's law, energy required to grind a specific material is constant for the same reduction ratio irrespective of its original size. It is given by Hp is equal to K log capital D by small d, where Hp is the energy which we are going to measure and K is a constant, capital D is the initial diameter and small d is the final diameter which we are going to achieve. Now, energy to grind particle of 1 inch size into 0.1 inch size will be equal to energy to grind particle of 3 inch size into 1.5. If you substitute this in the formula, if you divide 1 by 0.5 you get 2, similarly if you divide 3 by 1.5 you get 2. The application of Kick's law is for compression of large particles. According to Rittinger law, the energy required to grind a specific material is proportional to the new surface which is formed, which is given by Hp is equal to K into 1 by small d minus 1 by capital D. Now, this law is applicable for brittle materials which is undergoing fine milling. The third law is Bond's law, which states that energy required to grind a specific material into a specific particle size is always proportional to square root of product's surface area to volume ratio. Hp is equal to 100 capital E subscript I into 1 by root of small d minus 1 by root of capital D. EI is Bond's working index. This theory is useful for rough mill sizing, and the work index is useful for comparing energy efficiency of milling operations. To summarize these laws, Rittinger's theory talks about energy is proportional to new surface area formed. Bond's theory states that energy used in crack propagation is always proportional to crack length produced, and third, Kick's theory talks about energy is proportional to ratio of change in size. Now, what are the types of size reduction equipments? They are of three types. One are shredders, second glass crushers, and third wood grinders. Now, based on the requirement of your product size, one among these can be chosen. Let's look into the shredders. Now, shredders are mainly used to reduce the size of municipal solid waste. The common type of equipments used as shredders include hammer mill, flail mill, shear shredder, and hydropulper. Now, let's look into the detail about hammer mill. The hammer mills are often used in a large scale operation for reducing the size of the waste. It is an impact device and it consists of a number of hammers which is fastened to an inner disc, and the disc rotates at a very high speed. Sufficient hitting results in the crushing and tearing of solid waste. By this way, the size of the waste is reduced. And hammer mills can be of two types. The first one is one-way type and the other one is reversible type. This picture shows the one-way and reversible type hammer mills. Next type of shredder is flail mill. It is almost similar to hammer mill, but it provides coarse shredding. Operationally, flail mill are single pass devices and they are mostly used for bag breaking. The next type of shredder is a shear shredder. This shear shredder is composed of two parallel counter rotating shafts with a series of discs. The waste material to be shredded is directed to the center of the counter rotating shafts. The mechanism used is shearing or tearing. The next type of shredder would be hydropulper. Hydropulper is another method for size reduction of municipal solid waste. Inside the hydropulper, the solid waste along with water is added. The high speed cutting blades mounted on a rotor in the bottom convert pulpable and friable material into a slurry containing 2.5 to 3.5% solids. The non-pulpable material or tin, metal, cans, they are all pushed through a chute and ejected out. The ejected material is collected in a bulk elevator. The slurry which is collected at the bottom is taken out for further processing. This image shows a hydropulper. This is a second type of equipment which is used for size reduction. Glass crushers. Now, glass crushers, as the name indicates, is used for crushing glass containers. In some mechanical separation operations, glass is crushed after one or more separation steps and then it is removed. The crushed glass can be separated optically by color. The next type of size reduction unit is a wood grinder. Again, as the name indicates, it is used for grinding wood. Wood grinders are wood chippers used to shred large pieces of wood into chips. It consists of a revolving upper section and a stationary lower section containing a hammer mill. The continuous stream of shredded material is carried away from the grinder by a conveyor. Towards your right, if you see the image, the bottom you can see a ball mill where the wood chips are inserted into the ball mill and it is being shredded and the small particles are collected at the bottom. Other size reduction equipments are summarized in this table. Briefly, it includes slide grinders, chippers, bulky grinders, jaw crushers, rasp mills, shredders, cutters, clippers, hammer mills and hydropulpers. Each one have their own mode of action and application. For example, if you talk about slide grinders, the mode of action is grinding and crushing, and it is used for organic solid waste. The chipper, the mode of action for chipper is cutting, slicing, and it is generally used for the reduction of paper, cardboard, tree trimmings, yard waste, timber and plastic. Likewise, bulky grinders, it is used for breakable and friable materials. Again, the principle or mode of action is grinding and mashing. The shredders, cutters and clippers use shearing and tearing as a mode of action, and they are used for treating all type of municipal waste. Hammer mills and hydropulper we have already seen in detail. The jaw crushers are used for bulky solids, and the mode of action is crushing and breaking. Now finally, we will look into what are the criteria which you will choose while selecting a size reduction equipment. We have seen so many size reduction equipment, but there should be some criteria based on which you can select the proper size reduction equipment. First, it includes the operational characteristics. Example, what is the energy needed? How continuously you are going to operate and what is the maintenance requirement? Next, what is the ease of operation? You will also look into the consistency, noise production, air and water contamination requirement. You will also look into the land availability, height, noise and other environmental restrictions. Safety is also very important, so safety issues should be considered. Solvents and gasoline used in these equipments can lead to explosive vapors, and it will also generate sparks. So we have to be very careful regarding this. As a matter of safety, the size reduction equipment should always be placed separately, and you should use a explosive proof material. To conclude, today in this lecture we have seen what is size reduction, what are the different ways by which we can do size reduction. We have also seen what is the importance or significance, or why do we actually need to do size reduction. We have also seen what are the different mechanisms which are involved in size reduction and the various laws governing size reduction. Finally, we have also seen what are the criteria which you will look into while selecting a size reduction unit. Thank you.